All periodic trends can be understood in terms of three basic concepts. Rule number 1. Electrons are attracted to the protons in the nucleus of an atom. Electrons have a negative charge, while the nucleus, consisted of protons and neutrons, has an overall positive charge. Ever heard the saying, opposites attract? Therefore, electrons are attracted to the protons in the nucleus of an atom. The closer an electron is to the nucleus, the more strongly it is attracted. The more protons in a nucleus, the more strongly an electron is attracted. Rule number 2. Electrons are repelled by other electrons in an atom. So if other electrons are between a valence electron and the nucleus, the valence electron will be less attracted to the nucleus. That's called shielding. You might be wondering what valence electrons are. They are the electrons in the outermost shell. So when we say shielding, this is a nucleus, this is the valence electron. The electrons between these two, that is what shielding is. The more shielding you have, the less attraction there is. Rule number 3. Completed shells are very stable. By meaning very stable, that would mean atoms prefer to add or subtract valence electrons to complete shells if possible, because they are so stable. So we are moving on to ionization energy periodic trend. You might be wondering what ionization energy is. Ionization energy is defined as the minimum energy required to remove an electron from an atom. Electrons are attracted to the nucleus of an atom, so it takes energy to remove an electron. The energy required to remove an electron from an atom is called the first ionization energy. Once an electron has been removed, the atom becomes positively charged. So looking at our periodic trend, ionization energy increases left to right. Ionization energy decreases going further down, therefore only increasing going upwards. The furthest right hand upper corner, that is where the ionization energy will be the highest, and on the left bottom corner is where the ionization energy will be the lowest. You might be asking why. Why does the ionization energy increase moving left to right? This is because moving left to right across a period, protons are added to the nucleus, which increases its positive charge. For this reason, the negatively charged valence electrons are more strongly attracted to the nucleus, which increases the energy required to remove them. Electrons are also being added, and the shielding effect provided by the filling of the S subshell causes a slight deviation in the trend in moving from group 2A to 3A. The deviation also arises from the fact that removing an electron from a full subshell tends to take more energy than removing an electron from an unfilled subshell. Moving down a group, ionization energy decreases. Why? Each inner shell shields the more distant shells from the nucleus, reducing the pull of the nucleus on the valence electrons and making them easier to remove. Protons are also being added, but the shielding effect of the negatively charged electron shells cancels out that added positive charge. Going on to an example problem. Looking at a practice problem, arrange the following in order from low to high with respect to ionization energy, and justify the answer. So we're given the elements sodium, lithium, potassium, cesium, and rubidium. So if we look at them in the ionization energy periodic table trend, we see that they're all located in group 1. Now, if we want to find the lowest ionization energy, we would have to go down. And we see that Cs, which is cesium, has the lowest energy. So the order of lowest to highest ionization energy will be cesium, rubidium, potassium, sodium, and lithium. Oh, forgot the Na. And our explanation for this can be that Cs has more shielding, so there's less energy needed to remove an electron. And moving left to right, more protons are there, so there needs to be more ionization energy. So that is some of the reasons you could justify your answer. The energy required to move the first electron from an atom is also called the first ionization energy. Likewise, the energy required to remove the second electron from an atom is called the second ionization energy. The energy required to remove the third electron is called the third ionization energy. And it so increases the fourth ionization energy, fifth ionization energy, etc. The second ionization energy is always greater than the first ionization energy. The third ionization energy is always greater than the second, and so on. This is because once an electron has been removed from an atom, electron-electron repulsion decreases and the remaining valence electrons move closer to the nucleus, making them more difficult to remove. So, when we look at an example, we see that there is the greatest difference between one ionization, first ionization energy and second ionization energy. Therefore, this would be in an element the answer would be something that was in group 1, and sodium is located in group 1. So, sodium would be considered the answer. Okay. We will be moving on to atomic radius. So you might be wondering what atomic radius is. It is the approximate distance from the nucleus of an atom to its valence electrons. So when we look at the periodic trend for atomic radius, you can see that atomic radius, moving left to right across a period, atomic radius decreases. So moving left to right, it'd be decreasing. So the only way it'd be increasing would be going the opposite way, which would be right to left. And moving from left to right across a period, protons are added to the nucleus, so the valence electrons are more strongly attracted to the nucleus, decreasing the atomic radius. Electrons are also being added, but they are all in the same shell, all about the same distance from the nucleus, so there is not much of a shielding effect. So moving down a group, atomic radius increases. The reason why, moving down a group, shells of electrons are added to the nucleus. Each shell shields the more distant shells from the nucleus, and the valence electrons get further and further away from the nucleus. Protons are also being added, but shielding effects of the negatively charged electron shells cancels out the added positive charge. So bottom right left corner here has the most largest radii, and then the top upper right hand corner, this is where your smaller radii is located. So the pattern would be going across to get bigger. Okay. We're now going to arrange ions in order with respect to atomic radius. So first we need to know what cations are. When an electron is removed from an atom, that is when cation is formed. The electron-electron repulsions are reduced and all of the valence electrons move closer to the nucleus. Cations are often smaller than atoms. Anion is when electron is added onto an atom, forming an anion. Electron-electron repulsions increase, causing the valence electrons to move further apart, increasing the radius. So typically known as larger than atoms. So to compare the atomic radii of ions, the electron-proton ratio must be considered. Consider the following example that we're going to see. We need to arrange the following from high to low with respect to atomic radius. We're given calcium 2+, potassium +1, sulfur 2-, and argon. So we need to put these in orders. So we see that the amount of electrons that calcium has, since its atomic number is 20, we're going to put 20 first. But then we see a 2+. So by meaning if the charge is 2 plus, then there must have been 2 electrons taken away from the amount of electrons there originally is. So we need to subtract, because if it's positive, that means that there's more protons left than electrons. So if you think about it that way, you subtract. That's how you get 18. And now protons is just the same number as the atomic number. Potassium, if we look on the periodic table, potassium, we have 19 as the atomic number. So since potassium is also with a positive charged elements, we need to subtract 1 because it's, again, positive 1. Therefore, we subtract 1. The atomic number for sulfur is 16, so therefore has 16 protons. But then, since it's 2 minus, this time it's minus. That means we're going to add, because if the electron charge is negative for an element, that means that we have more electrons. So we're going to take the proton number and we're going to add 2, therefore making it into 18. Now, argon, which the atomic number is 18, is just going to be the same number of electrons because there's no charges. So if we're going to arrange the following into respect to high to low in respect to atomic radius, we are going to list them as, since we see that we notice that all the elements have the same number of electrons, so that's isoelectronic, and therefore what causes one element to be larger or smaller is going to be determined by the number of protons. So the element with the fewest protons will be the largest because its electrons experience the weakest attractive forces. So the expected order would be calcium 2 plus, potassium plus 1, argon, and sulfur 2 minus. So that would be our order and answer. So moving on, we're going to be talking about electronegativity. So electronegativity refers to how strongly the nucleus of an atom attracts the electrons of other atoms in a bond. Electronegativities of elements are estimated based on ionization energies and electron affinities. So looking at the pattern for electronegativity, we're going to see that moving left to right across a period, electronegativity increases. This is because protons are added as you move left to right, and therefore the attraction for electrons is greater. Moving down a group, electronegativity decreases. The reason why it says increasing is because, again, this is moving upwards. That's the only way for electronegativity that it would be increasing. This is likely due to shielding. The protons in the nucleus do not have much of an affinity for electrons. So if we take an example, arrange the following from low to high with respect to electronegativity. You see, when we look back on periodic table, fluorine was located right here. We're going to circle it. And what was the other number? Magnesium, sodium, and chloride. So this upper right-hand corner is where it's the highest electronegativity. Bottom left-hand corner, this is where the lowest electronegativity. So if we're looking from low to high, our answer would be, it'd be sodium, magnesium, because again, we're increasing the right, and chlorine, because it increases as we go up, and fluorine. So if we write our answer, that would be our answer.